General 210 Regulations Maintenance Forms, Records, and Publications. Let's delve into the meticulous process of making maintenance record entries, aligning with the regulatory framework set forth in Title 14 CFR Sections 43.9 and 43.11. The significance of this task is emphasized in 14 CFR Part 91, Section 91.417, which dictates the duration for retaining these records. It's crucial to recognize that compliance with CFR regulations extends beyond a mere regulatory obligation. These meticulous records wield a direct influence on the aircraft's value, especially in buy-sell negotiations. Well-organized maintenance logs contribute positively to the selling price, while the absence or incompleteness of records may adversely impact it. In essence, adherence to CFR regulations is not merely a bureaucratic practice, it is a fundamental aspect of ensuring transparency, safety, and the sustained value of aircraft assets in the dynamic realm of aviation. We're studying here the significance of temporary records in aviation, specifically outlined in 14 CFR Part 91 Section 91.417, A.1 and B.1. Temporary records are vital snapshots of an aircraft's maintenance, preventive actions, alterations, and inspections. Owners must retain these records until the work is repeated, superseded, or 1 year has passed. These records encompass a detailed description of the work performed or a reference to FAA-accepted data, along with the date of completion. They also bear the name, signature, and certificate number of the individual responsible for the return to service. The retention period ensures a comprehensive history of the aircraft's maintenance, contributing to regulatory compliance, safety assessments, and transparent operations. Compliance with the retention period is more than a regulatory obligation. It's a commitment to safety and transparency, showcasing dedication to maintaining airworthiness standards. In conclusion, temporary records go beyond paperwork. They represent a commitment to safety, compliance, and the overall health of aviation. Let's discuss the importance of permanent records in aviation, specifically outlined in 14 CFR Part 91, Section 91.417, A.2 and B.2. These records, which stay with the aircraft throughout its operation, provide crucial insights into its total time in service, the status of life-limited parts, time since the last overhaul, current inspection status, applicable airworthiness directive notes, and major alterations. They play a vital role in maintaining safety, compliance, and transparency in aviation. We're discussing here a transformative aspect of aviation maintenance, electronic records and data retention. Over the past 25 years, the landscape of documentation requirements for aircraft and related parts has undergone significant changes, and nowhere is this change more revolutionary than with the introduction of electronic data. The advent of personal computers brought the power and versatility of computing not only to the average person but also to maintenance technicians. Initially, technicians developed their own programs, tackling tasks like listing data on type certificate datasheets, airworthiness directives, and more. Soon after, commercially available programs emerged, often developed by computer-literate individuals who recognized the potential benefits of integrating computers into the aviation industry or by aviation professionals who believed in the industry's need for such technology. These initial programs varied in user-friendliness and sophistication. A diverse array of database programs is available, offering features such as data research, ads, service bulletins, supplemental type certificates, TCDSs, essential for proper maintenance, inspections, and data recording. They aim to improve the overall efficiency of technicians in managing records. The considerations that maintenance technicians need to weigh when contemplating the integration of electronic record systems into their workflow. This involves a thoughtful evaluation of several factors. Firstly, the size of the aircraft being worked on plays a pivotal role. Technicians should assess whether the electronic system is tailored for aircraft weighing less than 12,500 pounds, those exceeding this threshold, or a mix of both. Program features are another crucial aspect. Does the electronic system offer built-in templates specifically designed for the aircraft in question? It's essential to inquire about the availability of FAA forms within the program and assess the user-friendliness of the template for data entry onto these forms. Functionality becomes a key consideration. Can the system effectively calculate weight and balance data? Does it boast efficient word search capabilities? Is it networkable, allowing seamless collaboration? Updates and accessibility also warrant attention. Technicians should inquire about the method of updates, whether through US mail or downloadable from the internet. System capabilities come into focus, considering the maximum number of aircraft the system can handle. It's crucial to determine whether it can accommodate various types of aircraft, including single and multi-engine, fixed wing, and rotary wing, as well as both piston and jet engines. Tracking and exportability features are paramount. Can the system effectively track items removed from an aircraft? Moreover, technicians should assess whether the data is exportable to other electronic formats, enhancing interoperability. Forecasting capabilities add another layer of functionality. Can the system forecast items due for maintenance or inspection, contributing to proactive planning? While acknowledging that there isn't a one-size-fits-all program, technicians stand to benefit from gaining insights into the diverse systems available. Opportunities for exposure, such as trade shows, maintenance seminars, or EA renewal sessions, provide valuable platforms for technicians to explore the pros and cons of different electronic record systems. This commitment to continuous learning and personal improvement aligns with the professional goals of every maintenance technician. We delve into the comprehensive framework of light sport aircraft maintenance. This realm encompasses a diverse array of aircraft, including gliders, airplanes, gyroplanes, powered parachutes, weight shift, and lighter-than aircrafts. Over the past 25 years, LSA maintenance has undergone significant evolution, prompting us to explore the nuances and standards that govern this intricate domain. In the introduction, let's distinguish between two primary categories within LSA, special and experimental. This classification, introduced in 2004 under 14 CFR sections 21.190, 65.107, and 91.327, has become a cornerstone for understanding LSA. Moving forward, we recognize the pivotal role of industry standards and regulatory collaboration in shaping LSA maintenance. Notably, organizations like the Society of Automotive Engineers and the American Society for Testing and Materials play a crucial role. ASTM, in particular, has developed a comprehensive set of consensus standards for LSAs, covering design, manufacture, and use, with over 20 standards emphasizing quality and adherence to national and international regulatory structures. Now, let's focus our attention on the maintenance aspect, delving into the key insights provided by F248305, titled, Standard Practice for Maintenance and the Development of Maintenance Manuals for Light Sport Aircraft. This document serves as a guide, outlining various facets such as the structure of maintenance manuals, the significance of task-specific training, and the role of safety directives in LSA maintenance. Terminology takes center stage, shedding light on essential concepts within LSA maintenance. Phrases like annual condition inspection, heavy maintenance, and line maintenance acquire deeper meaning, providing a nuanced understanding of their significance in the LSA maintenance landscape. In conclusion, comprehending LSA maintenance extends beyond regulatory adherence. It involves a meticulous understanding of ASTM standards, guidelines, and the intricate details outlined in documents like F248305. As we navigate through this complex realm, remember that every term holds a story, and every procedure contributes to the safety and airworthiness of these diverse flying machines. Now, we immerse ourselves in the realm of aircraft maintenance manuals and their pivotal role in guiding the maintenance, repair, and alterations of light sport aircraft. AMMs, unlike documents requiring direct FAA approval, adhere to industry standards, with ASTMs setting a benchmark. These standards cover a broad spectrum, including general specifications, inspection checklists, and detailed instructions for various components like fuel systems, propellers, and electrical systems. The inspection, repair, and alterations section within AMMs plays a crucial role. It specifies the special tools and parts needed, the type of maintenance action required, line, heavy, or overhaul, and the level of certification needed for the task. Certification levels are explicitly stated, referencing existing FAA advisory circulars. This ensures that individuals with the appropriate qualifications undertake maintenance activities, emphasizing the comprehensive nature of AMMs in maintaining LSA airworthiness. Transitioning into the intricacies of line maintenance, repairs, and alterations for LSAs, we recognize the critical role of line maintenance, requiring a minimum level of certification, LSA inspection. This involves tasks such as 100-hour annual condition inspections, servicing fluids, and component removal and replacement, all guided by the maintenance manual. Common line maintenance tasks delve into components like batteries, fuel pumps, exhaust systems, and floats, including repair or alteration as per maintenance manual instructions. Examples range from patching a hole in the fabric to installing a strobe light kit. As we explore the nuances of heavy maintenance, repairs, and alterations, we discern the shift towards tasks requiring a certified mechanic, A or P or A&P, or an LSA repairman, maintenance with additional task-specific training. Examples include the removal and replacement of complete engine assemblies, primary flight controls, and landing gear-related tasks. Heavy repairs and alterations involve tasks like repainting control surfaces, structural repairs, recovering of dope and fabric, and the initial installation of skis and new additional pitted static instruments. The overhaul of components is an exclusive domain of the manufacturer or an authorized entity. An overhaul manual, distinct from the manufacturer's maintenance manual, is mandatory for items like engines, carburetors, starters, generators, alternators, and instruments. In essence, line maintenance ensures operational readiness, while heavy maintenance, repairs, alterations, and overhauls demand specific certifications and meticulous adherence to detailed guidelines. This intricate dance between different forms of maintenance is fundamental to the sustained airworthiness of LSAs. We delve into a distinctive facet of light sport aircraft maintenance, major repairs and alterations, and unravel the unique procedures entwined with this domain. In the realm of LSA maintenance, the landscape of major repairs and alterations distinguishes itself. Unlike traditional aircraft maintenance, LSAs do not necessitate FAA Form 337 for these substantial endeavors. Post-production acceptance testing, any subsequent major repair or alteration is meticulously scrutinized against the backdrop of applicable ASTM requirements. The evaluation process can be orchestrated by the manufacturer or an approved entity. This affidavit serves as a solemn confirmation that the LSA still aligns with the pertinent ASTM requirements. The onus of providing written instructions delineating the required certification level for the maintenance rests squarely on the manufacturer. These instructions, comprehensive in nature, also encompass any essential ground or flight testing protocols, essential to ensuring compliance with the original LSA acceptance test standards. A meticulous documentation and record-keeping process is mandatory for this maintenance activity, precisely as defined by the manufacturer. In this intricate dance of maintaining airworthiness, task-specific training diverges from the traditional FAA-approved training paradigm. Here, the mantle of responsibility rests solely on the manufacturer. This includes examples like engine manufacturers' overhaul schools or programs such as the EAA Sport Air Fabric Covering School. Safety directives within LSAs are distinctive in their origin. Contrary to FAA-issued safety directives, those in LSAs are the prerogative of the original aircraft manufacturer. In cases where an LSA incorporates a product that holds FAA-type certification, the responsibility to issue a safety directive falls squarely on the manufacturer's shoulders. A typical safety directive encapsulates a comprehensive set of details, ranging from tools and parts needed to the type of maintenance required, level of certification needed, detailed instructions and diagrams, and the prescribed inspection and test methods. The mandatory nature of safety directives stands, except for LSAs designated for experimental use. In essence, the intricate procedures governing major repairs and alterations in LSAs manifest through evaluations, affidavits, manufacturer-defined certifications, and the issuance of safety directives. These processes intricately weave together to uphold the airworthiness and safety of LSAs. If you click, like, and subscribe, and leave a comment, we will provide a coupon for a free PDF download, one of 9 ebooks. However, each individual can only download up to 1 out of 9 ebooks for free.